So you can use it if you've got a Twisted project somewhere that's like 5 years old, you can use it. And you have to, due to a little bit of specialness on how generators work, you actually have to use defer.return value with inline callbacks, because in Python, you can't actually return from a generator. So it does this wonderful thing where it raises a special exception to escape out of it. And that sort of reason is why yield from was introduced in Python 3.4. It works with regular deferreds, and a function wrapped with inline callbacks returns the deferred automatically. And you can also use other deferreds inside there. It's fine. It interopts, so you can have some portions which are inline callbacks because it might work really well, and then you have some that you need to use deferreds because of you want to use specifically how deferred lays things out. So, the main part of the talk, making Django asynchronous. Now, unfortunately, it's synchronous at its core. And Whiskey relies on it essentially being synchronous. I mean, it doesn't have to be, but there's some, most things are. OK. Yep. So the ORM does blocking I/O. It'll call something like psychopg, which will block. And making either of these things, either the Whiskey portion, like the request cycle, or the ORM is complex if we want to make them asynchronous. Asynchronous just can't be bolted on. It's not something that you can just chuck on. Everyone needs to cooperate because it's cooperative multitasking. One thing does something and it goes, I'm waiting for some I/O, do some other thing. And it waits, and then it waits, and then it waits. So it's all lots of little things sort of broken up, working together. And common sense says that asynchronous code is hard, and synchronous code is easy because, you know, everyone knows how to do synchronous code. But really, it's not just it's easy and it's hard. Each has trade-offs. Synchronous is easier to understand with code flow because it's one thing, then the next thing, then the next thing, then the next thing. And there's only one logical thread of execution. It goes down. And many libraries are already synchronous. So if you're starting out and you go, I want to download a web page, you can go import requests. That's all you need. But you can only really do one thing at once without some terrible hackery. It's very much suited to the response request cycle, but that's really all it's good at. You have a thing and you return a thing. It's not good at you do a thing and then you return a thing, but then you also return another thing later, like WebSockets. And persistent connections are quite hard to do in it, because when your request finishes, you can't do anything past that, really, because you've returned. Now, asynchronous code has massively scalable network concurrency. Because it can manage thousands upon thousands of requests at once, it'll let you scale up. And for things like WebSockets, which are quiet most of the time, then it works even better because you can have thousands and thousands of quiet WebSocket connections, and you don't need any threads to manage them. They just wait for some data to come in on the connection, and then select, or the reactor, however it's using, will say, hey, some data's come in, and here it is. There is multiple logical threads of execution. The code handling the request doesn't have to finish after a request is done, and you can actually branch out. So you can go, OK, so here's the request. I'm getting the user page. I'm getting some, like, their blog posts, and I'm returning it. But in one thing, you might have something that goes, OK, so next time the user browses this thing, we want to say, OK, they've seen this page. Like, for example, if you're testing new features, and you will go, hey, this is the first time you've come to this page. So it might go off and go set yes, now they've seen that page. You don't want to wait for the main thing. You don't want to wait for that because the main page is already loading. There's no point waiting for it, so you can branch out. And handling persistent connections is quite easy. If you use the reactor model like Twisted does, where you use it tells you when it's ready for reading and writing, it's actually quite threadless. The only reason you need threads is when you're dealing with synchronous code in asynchronous, you wrap it in a thread pool. So it means that you don't need to worry about thread starvation. You don't need to worry about the overheads of threads. And Python 3 adds some rather nice stuff that makes it easier to write. But you can get into callback hell. That's the thing that everyone complains about, even though it's not really that much of an issue these days with deferreds and futures and all that sort of thing. You do have to be a good citizen, blocking in your reactor loop is completely disastrous. If you block, everything falls apart. And doing I/O is a little bit harder because you need to be explicit when you're doing I/O. If you call a function, you have to yield it if it's doing I/O. You can't just have something that does I/O sometimes and just going, it'll probably be fine, because then that blocking there will block sometimes, and that's even worse, because then you'll go, oh, this function is calling into the database when it shouldn't, and it's blocking up the entire application. And Python 2, if you're stuck on it, lacks a whole bunch of the syntactic sugar. So you can't get the upsides of both, but you can get some water. Yeah. But you can try. So the standard amount of trying is a threaded WSGI runner. You have a server, and it runs Django in a thread. It's pretty standard. I'm fairly sure that's the main way everyone deploys it. In a thread or in a process, they're essentially the same. For the purposes of this, you still have the overhead of a thread, you still have the overhead of a process. Each thread is blocking, so it can't run multiple I/O operations at once. You need multiple threads to run multiple things. And to handle many concurrent requests, you need many threads. So if you want to handle 100 requests a second, you need 100 threads. And you need to have them all finish in a second, which, depending, sometimes doesn't happen, especially with some of the SQL that the ORM generates sometimes. Don't use, what was it? Once I made a query that ran in 60 seconds, and I didn't even realize it. It was great. So there's a project called Hendrix. Now, a twisted Django Reinhardt is Jimi Hendrix. We love puns. I've put a lightning thing up talking about puns. Russell knows what I'm talking about, puns. So it's a WSGI server that runs on top of Twisted, and it has some WebSocket support. It has multi-processing, so you can have multiple processors, each with multiple threads, so you can handle a lot of requests. So there's the URL. So if you just look up Hendrix Django Twisted, you'll find it. There's also Crochet, which runs Twisted in a thread pool beside Django. So you can run the reactor there, and it does the asynchronous stuff, and you've got the blocking thread here, and you just call into it, and it mostly works, and it lets you sort of tack some things on, but it's not perfect. Now, the future of Django. Everyone, pretty much in nearly every talk, has talked about channels. So who here knows what channels is? Actually, I didn't ask this at the start. Who knows what Twisted is? Who loves Twisted? Ah. Okay. Wish I didn't ask. So it's a brainchild of Andrew Godwin. So he brought us 1.7 migrations. He's a pretty good guy. He's British. What is there not to love? And it makes Django channels makes Django event-driven. One day I'll learn how to speak. It runs on you have an asynchronous server that serves the base request. So the client connects to the server, which is written in Twisted, or something else, doesn't really matter. And then there's synchronous workers that pick up those sort of things that it makes. I'll explain that. Requests and WebSockets events are now events sent through channels. So when you make a web request, it gets to that server. It publishes an event on a channel, and you write synchronous workers which handle these events, which are the workers. So they just go on a queue. So you have a HTTP request, it chucks it on a queue, a worker comes, and when it's ready, it picks it up and processes it and returns it. Workers can also put things on a queue, so another worker can pick them up. But because Django is synchronous and the queue is asynchronous, it can't get the result. Channels lets you use WebSockets. Right now, you can go and install it, and you can have WebSockets in your Django application. And if you don't care about the response, like a page view counter, you can just chuck something on a queue and increment it, and you don't care about the result. So you don't need to wait for your current request to happen for it to do some things that you don't care about. And the workers don't have to be on the same machine. You can have one or two very strong, beefy boxes that are exposed to the internet. And you can have your queue, and then you can have all the workers behind a firewall. So it changes how you deploy things, it changes your security a bit, and it just makes it a little bit nicer to think about when you're scaling, because you just can add more workers. If it's like a SQL query that's taking a long time, add more workers. If you need to handle more requests, add another front end. But not being able to get the results of the events you create is not great, because then you still have to wait for all the things to happen. You can't run multiple things at the same time and include it in the request. It doesn't solve the problem of Django being asynchronous. Your code can only do one thing at a time, but it sort of works. And your code is a few steps removed from the HTTP request or the WebSocket or all of things like that, so you lose a bit of flexibility, but whether that matters, who knows. So code, what does it look like? So here is Django channels. Here is an example. You have, so when a WebSocket, a HTTP or WebSocket event comes in from a client, it sends a message to a channel. And you implement consumers. So here it's a decorator, so consumer django.wsg.request. So when a request comes in, it will send a message to django.wsg.request, because it's a WSGI request. It will serialize that request down into JSON, send it, put it on the channel, and the worker brings it back, deserializes it back into HTTP request, and then do some things with it. Now, the first argument, as you can see there, is the response channel. So when you're finished, you can just boop, send it back. So you're given a channel to send the result to the consumer when it's called, yep. And in the case of a HTTP request, you send back a channel encoded response object, which is basically JSON. So the good thing about this is that you can have a front-end web server that's written in Go. It doesn't have to be written in Django. Just because it gets the raw request, it doesn't really do anything at all with Django. It just gets the request, serializes it down into JSON, and puts it on Redis. So you can have a super high-performance Go web server, and you don't really need to care about Go or know how to program in Go or all of that, because you're still doing Django and Python on the back end. The other thing means that you can write a Go or something back end to process some requests. You can do whatever you want. In the case of WebSockets, you just send back the content directly. So you get some bytes, and you send back some bytes. The front-end web server then returns it back to the client. WebSocket clients can be put into groups, so you can mass message using a broadcast. So if you have a chat room, you have a thing that comes in, you go, okay, it's this chat room, and you send it out to all the existing ones. Super easy. So what makes it different? Well, it doesn't really make your code asynchronous. It just makes runners that operate asynchronously but run your synchronous code. And it doesn't really tackle the hard problem of running multiple things at once or being truly asynchronous in Django. And it doesn't get all the benefits as if it did. But maybe that's enough. I mean, it's still good. It still lets you use WebSockets. It's still a vast improvement over what we've got now. Because the channels, the events on channels is just a much better way of thinking about it. Because it makes the scaling super easy. You don't have to have Nginx on 10 servers. You don't have to have all these dependencies on all your front-end web servers. You just have a front-end web server, and you have your workers, and you have a Redis. So you just can scale them all independently. It supports Python 2.7 and Python 3.3 plus. I know because I contributed the 3.3 support, because it runs the Twisted. So here is the URL, so check it out. I highly recommend it. And there are rumors, apparently rumors around the Django webs, that it might get included in a future version of Django once it is polished a little bit more and got some more docs. Then it should fit into Django quite well. It's really good. But why wouldn't you just use Twisted? I mean, that Django thing is old hat. It's not cool anymore. Twisted wasn't cool, now it's cool. Now it's still not cool. I'm not cool. I mean, I'm wearing a red trench coat in... No, it's not summer, it's winter. Here, it's summer home. So the future of Django, alternate version. So if channels doesn't become a thing, we're going to need WSGI 2. Something that can handle WebSockets. because currently it's very request response oriented. And any sort of future WSGI would have to support WebSockets. But what happens when WebSockets 2 comes out? Then or HTTP is no longer a thing. We'll need, WSGI 3. And we'll just